Now, sometimes you're going to have a coefficient of x. In this case, we've got 3. In doing so, that tells us how many times we're going to have to go around the unit circle to find the number of solutions of x that make this, or the number of values of x that make negative a half. So how we do that is by looking at whatever our coefficient is here and multiplying that by the domain. Basically, you want whatever you've got in here to replace this here, and you've got to change these numbers accordingly. So because we've got 3x, then our domain will change to 0 times 3, which is 0. This becomes 3x, and this becomes 6 pi. So in order to solve this, we've got to go around this thing. Didn't want to actually draw anything, I want to use a highlighter. We've got to start at 0, go to 2 pi, go to 4 pi, go to 6 pi. So, and that'll give us our solution. So basically, now because I've done these a number of times, I know that if we're looking for cos and it's negative a half or a half, then I'm dealing with this adjacent over hypotenuse, so this is pi on 3. So that's our pi on 3 triangle there. So now this tells me that x equals pi, pi over 3. Now, because I've got a negative value, I know that cos is negative in these two quadrants. Because we've got stations 2 there. So if we're going with pi on 3, that means we're going to be out here at pi on 3, and we're going to be down here at pi on 3. So to find this angle, we're going to be doing pi minus pi over 3. So we're almost at pi, but we're back a little bit. So this ends up being 2 pi over 3. And this is a little bit past pi. So this is pi plus pi over 3. So this ends up being 4 pi over 3. Now, like I said, that's the amount of times we've got to go around a unit circle. So x, in this case, will equal, we can kind of disregard this because this gives us a base angle, remember? It's all about the base. So now we've got 2 pi, so we've still got x. So we've got 3x, we've got 3x equals 2 pi over 3, and also 4 pi over 3. But we've got to go around some more. So if we go, so that's going around once. We're going to go around a second time. So we're basically adding 2 pi to both of these values. And because we're dealing with 2 pi, and because we're dealing with 3, that ends up being 6 pi. So we're adding 6 pi on 3 to these values. So then we've got 8 pi over 3, 10 pi over 3. So far we've gone around unit circle once for the first two values, then a second time for the second two values. We've got to go around a third time. So once again we add 6 pi on 3, so we'll have 14 pi over 3 and 16 pi over 3. So we're almost there. We've got to do one step. These 6 values are all 3x. How do we solve for x? We've got to divide everything by 3. So we imply that x equals 2 pi over 9, 4 pi over 9, 8 pi over 9, 10 pi over 9, 14 pi over 9, and 16 pi over 9. So they're the steps that we need to take. So first thing, expand and multiply our domain. That tells us how many times we've got to go around a unit circle, because that's what we're looking at. From there, we determine which triangle we use. So in this case, it was our pi on 3 because adjacent over hypotenuse is 1 on 2. And then, like I said, that's our base angle. Because we're dealing in the second and third quadrant, it is pi minus our base angle and pi plus our base angle. Or graphically, we draw our triangle, we draw both our triangles in, and we know we're going 2 pi on 3 across, or we're going 4 pi on 3. So from there, that tells us our first two values. Then we've got to look at how many more times we're going through the unit circle, and then if we've got something in front of x, we're dividing by that value to find out all the values that x can take. And if you're not sure, you can substitute any of these in place of x and see what it gives you.